In this lesson, we're focusing on how the number line is the perfect tool for working with rational numbers, which are all the numbers you know, integers, fractions, and decimals. The number line shows us two things: the exact position of every number, and how to compare them to see which one is greater or lesser. Once you master the number line, ordering any set of numbers becomes simple. Let's quickly review the number line structure. 0 is our starting point. As we move right, the numbers get bigger, and as we move left, the numbers get smaller. All positive numbers are on the right, and all negative numbers are on the left. The beauty of the rational number line is that even fractions like 1/2 and decimals like -1.5 have their own unique and exact spot. To plot a positive fraction like 3/4, we look at the space between 0 and 1. The denominator, 4, tells us to split that space into 4 equal sections. The numerator, 3, tells us to count 3 steps to the right from 0. Plotting fractions is just about knowing where to count. Plotting negative rational numbers is the same process, but you move in the opposite direction. To plot -1/2, you look at the space between 0 and -1. Since the denominator is 2, you divide that space in half, and since it's negative, you step one part to the left. Always check the sign first. Decimals are often easier to plot. In example 1, we plot -1.75. We know this number is between -1 and -2. Since 2.75 is the same as 3/4, we just move 3/4 of the way from -1 toward -2. It's almost at -2, but not quite. Here is the most important rule for comparison. The number farthest to the right on the number line is always the greater number. The number farthest to the left is always the lesser number. This simple concept is your key to comparing any pair of rational numbers, no matter how small or large, positive or negative. Let's use the rule for example 2, comparing 2 and -3.5. Since 2 is a positive number, it is to the right of 0. -3.5 is a negative number, so it is to the left of 0. Therefore, 2 is greater than -3.5. A positive number is always greater than any negative number. Now for a trickier comparison in example 3, -4 and -1.5. Both are negative, but if you look at the number line, -1.5 is closer to 0, which means it is farther to the right. Therefore, -1.5 is greater than -4. The number that is closer to 0 on the negative side is the greater number. When you write down your comparisons, you use symbols. The greater than symbol is, and the less than symbol is. Remember that the opening of the symbol, the wide part, always faces the greater number. So, if we say -1 is less than 0, we write -1 less than 0. When you have a whole list of rational numbers to order, the best strategy is to convert any fractions to decimals first. Then, you can simply imagine all the points plotted on the number line. Reading the numbers from left to right gives you the correct order from least to greatest. In example 4, we order the list 0, -3/4, 1.5, and -2.5. If we convert the fraction to -0.75, it's easier to see the order. On the number line, -2.5 is the farthest left and 1.5 is the farthest right. So the order from least to greatest is -2.5, -3/4, 0, 1.5. The number line is great for visualizing opposites. Opposites are any two numbers that are the same distance from 0. For example, 3 and -3 are opposites. They sit like mirror images on either side of the origin. When you add a number and its opposite, the result is always 0. This leads us to absolute value. The absolute value of a number is simply its distance from 0. We use vertical bars, x, to denote it. Since distance can't be negative, the absolute value is always positive or 0. The distance from 0 to -4 is 4 units, so the absolute value of -4 is 4. The absolute value rule works for all rational numbers. In example 5, the absolute value of -1.5 is 1.5. The absolute value of half is half. The sign doesn't matter, only the distance matters. When you need to compare two absolute values, you must find the distance of each number from 0 first. You cannot compare the numbers themselves. You must compare the resulting positive numbers. This is where the number line helps you visualize which point is physically farther from 0. In example 6, we compare the absolute values of -2 and 1.5. The absolute value of -2 is 2. The absolute value of 1.5 is 1.5. Now we compare 2 and 1.5. Since 2 is greater than 1.5, we conclude that the absolute value of -2 is greater than the absolute value of 1.5. In the real world, like banking, we compare debt and gain. Having $10 is definitely better than owing $20, which is written as -20. On the number line, 10 is far to the right, and -20 is far to the left. The comparison is 10 is greater than -20. Another great example is elevation. Sea level is 0. Everything above it is positive, and everything below is negative. A mountain climber at 100 feet is at a much greater value than a scuba diver at -50 feet. The number line perfectly models this vertical relationship. Let's use the number line rule for example 7. A submarine is at -50.5 meters. A swimmer is at -2 meters. To find out who is deeper, we look for the lesser value. Since -50.5 is farther to the left, down, it is the lesser number. The comparison is -50.5 is less than -2. The submarine is deeper. For your final challenge, plot the three numbers, -0.5, 7/4, and -2.5. First, convert all the numbers to decimals. Once you plot them on the number line, it will be immediately clear which number is the greatest. It will be the one farthest to the right.